Hey guys, welcome to Unit 13 review video. So this is encompassing both parts A and B, so all categorical and quantitative data. This is the second to last unit of the entire year, which is crazy to think about. We've made it so far. So at this point, hopefully you guys already have all of these formulas filled in from class. I'm just going to skip down to some problems. Scroll through to show you what I'm talking about. I'll do 2, 3, 4, 5, 7, sum of 12, 15, 18, 22, 25, 26, 27, 29, and 30. I tried to pick a variety so that I wouldn't be doing all the same problems constantly, which is what I try to always do. So hopefully that does... I hit everything I want to hit. All right, I go all the way back to the top. All right. So one of the things we talked about in this unit was events being independent versus not independent. So when we read the following events, we need to figure out what they are. So keep in mind that independent means that the events have no influence on one another. So if some event happens first, the probability of the next event happening is not influenced by whatever outcome happened in the first event. Okay, so independent is there's really no relationship between the probabilities that happened. Not independent means there is some relationship. So for question A, it says a person pulls a red marble out of a bag that has 5 blue and 7 marbles. So I'm thinking right there that's 12 total marbles. Okay, and they do not replace it. So does not replace is important to note, because that means you took the marble out and you didn't put it back. Then a person pulls another red marble. So we're doing 2 red marbles. Is the probability of pulling the second red marble out dependent on pulling the first marble out? The answer is yes. You have to realize that the first time you're pulling the marble out, you had 12 total marbles. So in a way, I'm going to actually answer this question down here. The probability of you selecting that first marble was 7 out of 12, because you had 7 marbles that were red out of a total of 12. But you took the marble out, you didn't put it back, so that means when you were selecting out of the bag, you didn't have 12 marbles anymore, you had 11. Additionally, you already took a red marble out, so the probability of you selecting another red marble is not 7 again, it's 6. Okay, so what you really just did, and I don't like to emphasize the formula, but what you really just did was you calculated this. The probability of selecting the first red marble times the probability of selecting the next, well, I can't repeat, the probability of selecting the next red marble given you've already selected a red marble. Okay, so that's really the formula you're doing, but I try not to emphasize that. It's really just thinking about it. Okay, so multiply across, you get 42 over 132, which if this was a multiple choice, maybe you'd see it as a decimal as well. So just be prepared for different forms of the answer. Okay, next question. If a person flips a coin and notes that it comes up heads, a person flips a coin and notes it comes up heads, then the person rolls a standard 6-sided die and notes that it comes up with a number less than 3. Is the probability that the number came up less than 3 dependent on getting a head when flipping the coin? No, it's not like you flip a coin and you get heads and then magically you're more or less likely to get a certain roll of a die. So flipping a coin and rolling a die are independent events. Okay? One event happening has no influence on the second event happening. Okay? So find the probability of flipping heads and then rolling a die. So since the events are independent, all you're doing is the probability of heads times the probability of getting a number less than 3. So getting heads is 1/2. Number less than 3, so what is that, 1 and 2? So that's 2 out of 6 total options. Okay, so that would be 2/12, or you could see it as 0.167. So again, these were independent, these were not independent. There's a 34% chance that a person picked at random from the population is a regular smoker of cigarettes, and Oopsies, I don't want to emphasize that. And an 18% chance that a person selected has emphysema. Okay, so I like to try to dissect this as I'm reading it. So 34% chance that someone's a regular smoker. So I'll call that P of S. 18% chance they have emphysema. So I'll call that P of E. If the percent of the adult population that are both regular smokers and suffer emphysema is 14%, find the probability a smoker, find the probability of being a smoker or having emphysema. Okay, so the probability of S and E they gave me, that was 14. They want the or. Okay, they gave you all of the pieces for the or formula. So you need to know the probability of S or E is the probability of S plus the probability of E. Take away the overlaps. That's the and. Okay, so at this point, I just plug in my info. Okay, and this is the overlap because you don't want to count these people twice, and that's where you get 0.38. So there's a 38% chance that you're going to have a person who is a smoker or has emphysema. All right, so we got a table below of preferred subjects and male versus female. I want to know if the events are independent. In order to assess independence, we need to calculate the probability of being female and the probability of female given they said they preferred social studies. This is the formula, okay? The only other possible way you could calculate independence is if you did the probability of social studies and then social studies given female, okay? I always like to go in the order given, just it helps me be consistent, but technically you could calculate this as well. What you can't do is flip these, okay? That's a completely different probability. That's not how you assess independence. Make sure you're also labeling your information, okay? We need to know what probabilities you're calculating so that you can receive credit. All right, so probability of just being female. We have 30 out of a total of 57. Okay, probability of female given they said they preferred social studies. So that means we're only looking at the people that said they like social studies. So that's 19 students. Of the 19, 10 are female. Okay, so I'm showing where I'm getting the numbers from the table. I'm dividing, and I'm not going to pull up the calculator. You guys can divide this. For the first decimal, you'll get 0.52631. And you actually get the same decimal, about 4 decimal places there, 4 or 5 decimals. You'll get the same decimal for the second probability. So because these numbers match, your events are independent. Okay, and I always think about this as I added extra information here, and it didn't influence the original probability of just being female. So therefore, preferring social studies has no influence on being female. So therefore, they are independent. And when it says justify your answer, that's what I just did. I showed my work, and I said whether or not they were independent. At Oostburg College, it is known that 21.8% of the population is enrolled in the engineering program. So I'm going to do this. Probability of being in engineering is 21.8%. It is also known that 20% of the student population participates in the marching band. So just being in the marching band is 20%. Of the students in the marching band, it is known that 60% are not in the engineering program. So that's important. I highlighted this, okay? This isn't of the entire student population. This is of just the students in the marching band. Okay? We need to take this data and fill it in below. Okay, so we're going to do a hypothetical 1,000 table, which means we're just going to pretend there's 1,000 students in the population. Okay, the original part said that being in the engineering program was 21.8%, so that means 218 students out of our hypothetical 1,000 will be in the engineering program. Then 20% of the population, so again, that's everybody, is in the marching band. So in marching band, this will be 200. Okay? Now, this is where it got important. Of the students in the marching band, so that's of the 200 students, it's known that 60% are not in the engineering program. So that means we need to do 60% of my 200, which is 120, and that's what goes in this table. Now we have everything we need to fill in the rest of the table, which you guys are pretty good at. Everything just needs to add up in the margins. Okay, so I just filled those in. All right, what is the probability that a randomly selected student is in the marching band and engineering? Okay, so in marching band and engineering, that's 80 out of 1,000. So again, this is really what I'm calculating, marching band and engineering. Okay, and it says to the nearest thousandth, so that's 0.08. Well, nearest thousandth where necessary. That one's not really necessary. Probability that a randomly selected student is in the marching band or engineering program. So that would be the probability of marching band plus the probability of engineering. Take away those that are in both because we don't want to count them twice. So being in the marching band was 200 out of 1,000. Engineering program was 218 out of 1,000. And being in both, so engineering and marching band, was the 80. Don't want to count those guys twice. And you'll get 338 in that numerator over 1,000, so 0.338. Lastly, is being a marching band member independent of being in the engineering major? So what I'm going to do is calculate probability of being in marching band first, and then marching band given engineering. Okay, so probability of marching band we said was 200 out of 1,000, which is 0.2. Marching band given they're in the engineering program. So given they're in the engineering program, 80 of them are in the marching band. Okay, and I would get 0.367. So notice how the probabilities are not the same. I added extra information to this and it had an influence on the original probability. In fact, the original probability, which I think of as like my baseline, has increased. So what this means is you are more likely to be in marching band given you're in the engineering program. And that's what you'd see written on my answer key. So you are more likely to be in the marching band given you're in the engineering program. Literally just read this word for word. And I said more likely because this increased. Had this probability decreased, I would have said you're less likely to be in the marching band given you're in the engineering program. Okay, and that's what you would do for explain your results, but I'm not going to write that out. You can read that later. All right, so in the second part of the unit, we did some descriptive statistics of quantitative data, which is where you measure data with a unit. Okay, just to review how you would do this in the calculator. Calculator. Yeah. Thank you, Windows time. Okay, so how you do this in the calculator is you go to Stat and then Edit. If you need to clear out data, make sure you do that. Clear. Okay, and it looks like I have scores of maybe some tests and frequencies. So that means you have 3, 5, 7, 15, 6, 20s, and so forth. So I'm just going to go through, enter in my scores. Okay, and then I do 3, 7, 6. All right, good. So I entered my data in. Now, unfortunately, my calculator on my computer does not have updated software, so I'm not going to get a prompt screen, which kind of stinks, but here we go. You go back to stat, calculate, and it's going to be one variable statistics. Now, if you have a TI-83, this is what your calculator would look like. If you have a TI-84, it'll prompt you and ask you for your X list, your frequency list, and then calculate. Since I don't have that prompt screen, I actually have to manually type that in. So I would have to hit L1, comma, L2, because that's me telling the calculator I have a frequency list, and then hitting enter. Ooh, that's not the number that I had written. Sorry for the technical difficulties. There's a life lesson in this. Make sure you check over the data when you enter it in. I accidentally put in 50 instead of 20 for that score, so yikes. So I apologize. These are the numbers you should be getting. So if you were following along and being like, that's not what I got, or that's not what's on the answer key, yeah, I made a mistake. So make sure you always check over your list. So learn from my mistakes. Anyway. The first number here, the X bar, that's the mean of your data. So that's 30.2. The median, actually says it right down here if you scroll down, is 30. So that's the middle of your data set. The mode, I think it tells you at the top. No, maybe it's lower. Oh wait, it doesn't tell you this in the calculator. What am I thinking? The mode is over here. You can just tell what happens the most. What number happened the most? We say it was 35. You have 20 of those. So your calculator actually doesn't tell you that. Okay, you have to just look at your data. Lastly, they ask you for your quartile information. So Q1 is listed right there. So that's your 25th percentile. Median would technically be like Q2. That's where your 50 percentile is. Q3 is 35. And then there's your max. Okay. The thing that the calculator doesn't tell you is your IQR, which is always quartile 3 minus quartile 1. Okay. So I just said that quartile 3 was 35, quartile 1 was 25, so you would just subtract those and get 10. Okay. Standard deviation in your calculator. That's this number right here. It looks like an upside down baseball cap. That's a Greek letter called sigma. So your standard deviation is about 9.8. Okay, and your range is the max minus the min. So the max I said was 45, the min was 5. So your range is 40. Okay, so I didn't fill in all these pieces. That's 30, but you get the idea. Okay, now the thing about IQR, it gives you an idea of the spread of the data. So if I were to do a box and whisker plot, okay, and I had an IQR, which represents this box because it's Q1 versus Q3, and it's rather large, that would tell me my data is rather spread, pretty far apart, because 50% of my data would have a pretty wide range here. But if I drew a box and whisker and the box looked like that, that tells me the difference between Q1 and Q3 is really not that big. So that means 50% of my data is really close together in there. So that would tell me that the standard deviation, or the spread of my data then, is really pretty small. Okay, so what does this large standard deviation indicate about the set of data? It would mean that my data is spread and varies away from the mean. It's about how far typically your data falls from the mean of the data set. All right, coming down to 12. If the scores of a standardized test are normally distributed with a mean of 460 and a standard deviation of 75, find the probability that a test picked at random would have a score larger than 720. When it's asking you to find the probability, that's the same thing as asking you to find the area under the normal distribution curve. And we do that using normal CDF in our calculator. Okay, so here's a sketch of our normal distribution curve. Okay, notice I'm just saying normal, not standard normal. Standard normal would mean the middle of this is 0. Since the mean is 560, that'll be the middle of my distribution. Okay, 720 would be up here, and I want to see a score larger than that. So you want to find the area to the right. So when you type this in your calculator, you use normal CDF. Okay, and that's second var's option 2. Okay, and you'll see that I have the old operating system on my calculator, which means it isn't prompting me with the information, so I'd have to remember it. But thankfully, most of you guys have updated software. The first number you have to type in is the lower bound. So in my case, it's a 720, comma. My upper bound is going to be infinity. So you could either do 1e, which is second comma 99. That's the calculator's code for just like a super large number. It's kind of like saying positive infinity. Or you could even just hit a bunch of 9s. It just needs a really big negative number. Comma. The second number it asks you for your prompt screen is the mean. So that's 560, comma. And then lastly, it needs the standard deviation, which is 75. Okay, so if you had the prompt screen, you would just hit paste after this, and then you'd actually be at the same place that I am right now. Okay, so I hit enter. There's my answer. So 0.0164. Okay, and that's your answer. Did I ask to round? Oh yeah, nearest 1/10 of a percent, so 1.6%. Okay, and I would want to see your calculator work. I'm not going to write it out now to save time in the video, but keep in mind that I would want to see that, so I know what you're typing in your calculator. All right, similar ideas for the next ones. You want to find one that's less than 500. So on your standard, or excuse me, on your normal curve, 500 would be down here. Okay, the only difference now is your lower bound, which I always think lower left, it's like your minimum value here, is negative infinity. Second var is option 2. So I do negative infinity or negative a bunch of 9s, that'll work. Okay, to 500, that's my upper bound. Mean is still 560, standard deviation is still 75. Enter. Okay, so 21.2%. Again, I'd show your work, but I'm just kind of quickly going through this. And then the same idea for C. You want to be between a 500 and a 600. Okay, and the only difference there is that your lower bound is 500, your upper bound is 600. I'm not going to do it. You get the idea. Just calculator work. But when I'm asking for the probability, I'm asking for the area, which means you're using normal CDF. Okay. 15. The prices of printers in a store have a mean of $240 and a standard deviation of 50. The printer that you eventually chose costs $340. What's the z-score? Okay, I want to emphasize here that a z-score means how many standard deviations you are above or below the mean. Z-score is calculated by your score, which in this case would be a cost. My cost was $340. Take away the mean, so $240, divide by the standard deviation, which they said was $50. Okay, so when I calculate this, I actually end up getting 2. So that means my printer is 2 standard deviations above the mean. Okay, can a z-score be negative? Absolutely. If this was a negative answer, that would mean that it's below the mean by 2 standard deviations. Okay, z-scores are beneficial in describing data because it allows you to compare 2 different data sets. It's helpful to understand where you are relative to everybody else on that same test, and it allows you to compare to another test that may be more difficult or easier, because you can see then how you did relative to everybody else on that test. All right, at a costume party, 7 girls wore masks, 9 boys did not. There were 15 boys at the party and 20 students did not wear masks. What is the total number of students at the party? So for this type of problem, you really have to organize your data. So you could use either a Venn diagram or a two-way table. I'm going to go two-way table because I think that it's a little bit easier. So we got boys and girls at the party, masks and not masks, we'll say. Squeezing it in here. Okay, so filling in the info. We had 7 girls who wore masks. So girls, masks was 7. 9 boys did not. Boys, not masks. 9. There were 15 boys at the party. Okay, that sounds like a total of boys. There were 15 boys at the party, and 20 students did not wear masks. So that's a total of students that did not wear masks. What was the total number? So essentially, I need to work towards that. So filling in my table, if this is 9, this must be 6 to sum to 15. If this is 9 and this is 20, this must be 11, which means adding across here would give me 18. And right there, I actually can get the answer by just summing those together, and it gives me 33. You could have also found this number to be 13, and the sum of those will give you the same answer as well. So that would be a good way to check to make sure you added your numbers correctly. All right, if the probability that an event will occur is x over 4, what's the probability it will not occur? So maybe I'll just call it event A. It wants not A. So the event, it did not occur. Whenever you calculate what's called the complement of the event, it means the events add to 1. So I'll do 1 minus x over 4. Now you can see that's none of the options. So I'm going to rewrite this as 4 over 4, so I have a common denominator. And as one fraction, I get 4 minus x over 4, which is option B. All right, the SAT is taken by most high school students planning to attend college. In a recent test, the SAT score was a 1030. Test score was 1030. Jeremy is planning on taking the test in May. If the mean is still a 1030 and the scores have a normal distribution at the standard deviation of 120, what is the minimum score Jeremy can get to be in the top 15% of examinees? Round to the nearest tens place. Alright, so on a normal distribution curve, we're saying that the center of that distribution is a 1030. Jeremy wants to be in the top 15%, so he has some unknown score there that separates him from the upper 15%, which as an area would be 0.15, and the lower 85%. So that's 0.85 as an area under the curve. Because I know the area and I need a data value, that tells me this is an inverse norm problem. So it does the opposite of finding an area. You know the area, you're finding the value that gives you that area. Now what's important to note is that inverse norm will only take the area to the left of a data value. So while we're talking about the top 15%, we're really talking about his percentile, which is everybody he did better than. So when I put in the area, I'm going to put in 0.85, not 0.15. Otherwise, that would put him down here, which is what you don't want to do. Okay? The mean of this is a 1030. Standard deviation is a, what did it say, 120. And then you just plug it in. So again, this is under your VARS screen, so second VARS, option 3. Okay, and then I don't have a prompt screen, so I have to actually type it in. Boom. Okay, so you have to get, it says 1154.3, but it said nearest tens place, which would be right there. I'm looking to the right, and I have a 4, so that means he needs an 1150. Okay, so be careful. That didn't say tenths, it said tens. What is the z-score that you computed for that? So essentially now I'm computing how many standard deviations he is from the mean. Z-score is his score minus the mean, which was a 1030, divided by the standard deviation of 120. Okay, and if we plug that in, you actually get 1 as an answer. So that means if he gets in 1150, he will be 1 standard deviation above the mean. Whenever we describe the shape of a data set, we're talking about approximately normal, skewed, and then we talk about skewed left or right. And center is that balancing point, where it looks like the middle of that data set is, so that the data would balance. This first set of data looks like I can draw a nice smooth bell curve over it. So what that tells me is that this is approximately normal. You could say approximately symmetric as well. And the center, if I had to guess, is probably like right around in there. If I draw in that like fulcrum looking shape, it looks like my data would balance there. So I'd say like our center is approximately 71. Now the data down here, if I draw a curve over it, it doesn't look very symmetric, okay? This tail part is on the right, so that's what tells me the shape of this is skewed right, okay? The center of my data looks like it's like right in this range. Looks like it might balance around there, a little closer to the peak, so I'll say my center is about 15. Okay, and that center is actually the median. Okay, the median, because most of your data is over here. So the middle value of your numbers is going to be closer to where most of your data is. If I had to approximate where the mean is, I'd say the mean is probably over here in this area. So your mean is getting pulled to the right because of these data values. Okay, and that's why it's called skewed right. The mean is getting pulled to the right. In an approximately normal distribution, the mean and median would be the center here. So this is not only the mean, it's also the median. They'd be about the same right in the center of that distribution. But skews cause them to separate. Okay? If my distribution looked like this, that's skewed left. So that would tell me my median is about right there, and my mean will be to the left of it. So when I know the mean and median, I can figure out whether my data is skewed or not based on how close they really are to each other. So if they're really close to each other, my data is approximately normal. If they're separated, depending upon where the mean is relative to the median, it tells me the skew. All right, 27. A student is chosen at random from a student body at a given high school. The probability that the student selects math as their favorite subject is 1/4. I like to keep track of my data. Probability they are chosen and they are a junior is 1/16 out of 459. And the probability that the student selected is a junior or chooses math, so junior or math, is 47 out of 108. What is the exact probability that the student selected is a junior whose favorite subject is math? They're asking for the and there. Okay, now this is where some students will say, well, can't I just multiply these two probabilities together? Because that's what we said before, right? And if we have an and, we would just multiply the probabilities. That's only true if the events are independent. And I don't know their independence right now, so I can't just multiply them. Now, because of that, when we write this question, we give you the or. There's a reason for that. We're giving you the or so that you can solve for the and. So the probability of the or will equal the probability of junior plus the probability of math. Take away the overlap. So that's the and. That's what you're solving for. And then I just plug in everything else. So junior was 1/16 out of 459. 47 out of 108. And at that point, guys, is just to solve for x. You should get x equals 31 out of 459. Okay? And that's the work you would show there, and you would just do that in your calculator. Now, this question was from the January exam in 2018, and there actually was a second part to it that said, are the events math and junior independent, like something to that regard? So I'm actually going to add that over here because I think it's a good conversation. So are math and junior independent? Okay, so in order to calculate this, you'd have to compare the probability of choosing math and math given junior. And some students may choose to come up with a two-way table, but it's actually easier than that. Probability of math they gave you, that's 1/4. The probability of math given junior you don't know, but you can calculate it using the conditional formula, which is always the probability of both events, so the and, divided by whatever's given. I just solved for this in my previous part. This was 31 out of 459. The probability of being junior was 1/16 out of 459. Those would actually reduce, so I'd have to do 31 over 1/16 in my calculator. And that's 0.26 some. Okay, as for this is 0.25. So since, I should probably add another decimal place here. Since those decimals are not the same, they are not independent. And that's what the second part of that question was on the reasons. But you can see how you had to know your conditional formula in order to even be able to solve it. Or you could write a two-way table. Okay? Last couple questions. Yeah, I know this is kind of a long video. At a swim meet, there are two different heats, heat A and heat B. The mean time for heat A was 3.54 minutes and the standard deviation of 0.12 minutes. Heat B had a mean time of 3.52 with a standard deviation of 0.08. Assume the times are normally distributed. Matt was in heat A and swam between a 3.33 and 3.48. Anthony was in heat B. What time interval must Anthony swim in order to claim he swam as well as Matt? Whenever we say as well as, we're talking about matching z-scores. So I have to first figure out Matt's z-scores, which is how many standard deviations he was from the mean. So I called it ZL for his low z-score. So he swam at minimum 3.33. Okay, so his score minus the mean divided by the standard deviation of his heat, and I'm getting -1. And then 3.48 minus 3.45 divided by 0.12 will give you 0.25. So he's one standard deviation below the mean or 0.25 above the mean. Okay, so now Anthony needs to match those. I don't know how he swam. I'll just call them X and Y. But in his heat, the mean was a 3.52. And the standard deviation was 0.08 of a minute. Okay? And this at this point would just be a very quick cross multiply and solve. Multiply, add over 3.52. And you get 3.44 and 3.54. So your range would be between 3.44 and 3.45. So that's the interval he would have to score in. Whew. All right, last question. On the last test, the mean score was an 82 and the standard deviation was 5. What data value, Lila scored a 90 on the test. What's her percentile rank? All right, so assuming they're normally distributed data, which we probably should have said there, mean of her data set would be right here in the middle, 82. She scored a 90. When we calculate percentile, it's always what percent she did better than. So that's the area to the left. Since we're finding area, that means it's a normal CDF problem. Her lower bound would be negative infinity. Upper bound would be a 90. Mean is an 82, and standard deviation was a 5. So this is what you plug in your calculator, and you end up getting like 0.945, which means she scored at the 95th percentile. Okay, if there's 20 other people in the class, how many students scored better than her? Well, if she's scoring at the 95th percentile, that means that 5% did better than her. So 5% of 20 is 1. So 1 student did better than her. All right, and that's the review.